Welcome to the Virtual Productions Gathering. It's an event that we are putting together to showcase a bit the work being done in virtual productions. This is part of some initiatives that we've been having internally in our university of start developing some virtual productions. We've been having a lot of interesting interesting support internally and externally for actually continue developing this. We've been approached by many companies, by many institutions to actually work in this area. And because there was so much interest, we felt that would be interesting for us to expose this to our students, but also to continue this effort within our university. And that's why I invited three experts in virtual productions and that are working in the field for some time. And I would like to introduce first Maarten, then will be Emanuele Salvucci from Italy, working in Prometeo Lab, and he has working in Unreal for a very long time. And then finally from Unreal Engine and Epic, specifically Mark Flanagan. So I would actually ask everybody to mute themselves for the presentation, and also put the video out because Martin is going to be showing his screen. I might come in and pop in sometime, but I would like everybody, if possible, to mute. Otherwise, I'll mute you guys myself. If you have any questions, please raise your hands, and we'll address the questions mainly towards the end, because we expect a lot of people to be interested in working in visualizing what they're seeing. So to avoid major interruptions, we'll just make note of your questions and ask the questions more towards the end. And that's basically it. Make sure you raise your hand before you start speaking, and I'll pass the word to you guys. That's about it. Thank you. And Maarten, take away.
Okay, thank you. Um, just checking which screen to share with some audio. Should work. Screen 2. And now getting you guys back. There we go. Okay, you should see my screen now. I suppose that's okay. Otherwise, you should say now it's not. I'm Maarten Francq, actually working at the Royal Institute of Theatre, Cinema and Sound, also known as the RITS in Brussels. And we're kind of becoming a partner school of Breda University. We do kind of the same things, and we're very interested in working together. What I will show today is a bit the history of XR. I've been involved in XR since 2016, where we started our first experiments on projecting on a cube-like interface. I do have different hats. So I have my RITS hat. I also work for Malf Media, which is a Scottish company been involved in XR since the start. We do work a lot together with White Light in London, which is also a big smart stage provider. So the things I will be showing, I don't take credit for them all. I've been involved in many of the projects that I will show, but sometimes I also steal from colleagues. Where possible, I noted where it comes from. So it's not me who created this all, but normally I do know the guys who did. So if you have any questions about one of the things I show in the PowerPoint, you should be able to see who created it, but I can always relate you to whoever that is. So ready to go. I start with a little movie who should start playing. There we go. This is Michael, this is my colleague, and there we show an implementation of XR on an easy screen, just one screen in a hotel lobby, where we recreated the hotel lobby in 3D and used just one LED wall on the back and a floor, just so not the usual cube, to create what was actually the first hybrid event where we combined XR and AR, so the people in the room could actually see what was on the screen. I'm not going to play all movies completely because that would take too long. First of all, the origin of it all, where it started, at least for me. Let's see. December 2016, a demo created by Bait, Mediatek, and Notch, where they showcased the first time the possibility to use a tracked camera and Notch as a render engine to show some video on the screen. I'll show you the video. Okay, so as you can see, for 2016 is quite impressive already. But it went on. We had Eurosport very early who asked to create something based on this to be used on the Pyongyang Winter Olympics, and it actually ended up with a prototype.
Hello, I'm
This
Martin
is the proof of concept.
welcome to the Magic Box. Today, Marcel Hirscher won yet another medal. He lands too far to the side. Tricking Hirscher. And if we...
I suppose you all know what XR is about. I may use this example just to quickly explain what you're looking at. So we have a camera on a crane that is tracked, so we know the position of this camera. The position of this camera is sent to the render engine, which was in this case Notch. In Notch, there's a 3D model that has been textured that renders from the same point of view as the camera is looking. We send this out to the disguise server who is distributing this content onto the screens. And then we just take the image from the camera live, if you want multi-camera, and you can cut it. You can cut it live. You can see here this is an early implementation because you can clearly see the lines of the LED floor, and there's still a big difference in color between the back wall where he's standing in front and the floor, which has been solved in the meantime, but it was one of the big problems. Now this has really been used on Eurosport and has won some prizes. I think it's IBC Innovation Award 2018, if I'm not wrong. So then we went a bit further. This is a white light video.
An impressive and controlled win.
Okay, so as you have seen in the video, there was a real window from the studio outside to the Rode Plein, Red Square, but the view was much too small to do something with it. So what happened here, some cameras were put outside and reused in real time inside the XR studio. So which made it possible to make this big view behind, which is actually not there. It's only only this part is a real view, and which made it possible to integrate those screens into this design.
From the World Cup favourites, we used that word at half-time, and they were in complete control in the second half. And an impressive and controlled win from the World Cup favourites. We used that word at half-time, and they were in complete control in the second half. And an impressive and controlled win from the World Cup favourites. We used that word at half-time, and they were in complete control in the second half. And an impressive and controlled win from the World Cup favourites. We used that word at half-time, and they were in complete control.
So this will give a view.
Good afternoon. Day 2 of the 2018 World Cup, and we'll be building up to Morocco against Iran very shortly. Peru are out, France are through, and Denmark will most likely join them. Australia still has...
Okay, on to the next one.
My name is Michael Alfar from Mouth Media. My role in this project is content designer. Together with Andy at Whitelight, we've been exploring how we can blend augmented reality, virtual reality in an immersive studio environment.
So the IBC exhibition is giving us a chance to present our tech lab in the Future Zone. And that tech lab is focusing around how we make the most of mixed reality in a broadcast environment. In our tech lab for IBC, we've got a digital canvas behind me that's been created using a number of LED video screens. They are being driven from a disguised media server, which is running Notch on it natively. So we're getting real-time generated content. Then we're taking mostly star tracker data that are on some broadcast cameras, taking that into Disguise to track where everything is in 3D space. There are some big challenges with mixed reality, augmented reality and virtual reality in broadcast. I think the key to making it successful is to make it believable. So too often at the moment there are elements which are virtual or augmented which don't really blend with the real environment. What we're trying to do here is actually use the real environment as a background and make that seamlessly blur with the virtual and augmented elements.
As a 3D artist, Notch has enabled me to go onto a couple of other canvases. So now we can seamlessly crossfade into augmented reality, virtual reality, creating 360 videos, processing Kinect data.
Some of the big advantages of using Notch in this environment in broadcast is that we've got the ability to make changes completely live and see those updates instantly. The lighting is absolutely crucial, and Notch allows us to take the lighting operator or the lighting designer is able to actually control that lighting in exactly the same way they're always used to doing. I think for broadcasters a big challenge at the moment is the expensive resource they need to be able to deliver these projects, and the Notch workflow allows you to use existing resource, 3D artists and 3D modelers.
Someone with no background in real-time content generation, for me, it is really easy to produce my assets in the packages that I'm used to, 3D Max, Cinema 4D, or any other 3D modeling package, import them into Notch, texture them and light them in there and get instant results. It speeds up the workflow, it opens up new possibilities. You instantly see what you're doing, so you don't have to wait for the render to come back. You just connect nodes and see where it takes you. That's a very exciting part of it.
Okay, it was a bit of promo, but we were very heavily on the Notch render engine at the time because we didn't discover yet what was possible with Unreal, mainly because Notch allows to intervene into your scene in real time. So you can connect your Notch laptop to a server where a Notch block is running, and you can in real time change almost everything inside. So that was for us the main reason we worked with Notch. We moved on and we are now using a combination of both. So we're using Unreal and Notch together on the same server to drive and to generate our content. Then a little jump to Holland. We come from live entertainment, so I'm not originally a broadcast guy, we come from live entertainment, and we said, okay, why not using this XR, AR technology and bring it to a big stage? So we had been working in the past with Dutch singer Marco Borsato, which is in Holland still one of the biggest crowd gatherers. So we were allowed to play, I think, 4 or 5 shows in the Cup in Rotterdam, if I'm not wrong, where we did actually the first live AR theater show. It's not theater, arena show. So what we did, we did put 4 tracked cameras in the stadium, and we put up one of the biggest screens I had ever seen, and we used that as a mirror for the people who were attending the concerts, so they could see themselves augmented with 3D environments. This is not the right one. Let's see if I can get it a bit further. There we go. Sorry. So what we have here is a view from 2 cameras on the stage of Marco Borsato. We have the view that he has, and we have a view from the side. So this is the view that Marco Borsato has from his stage. This is the view from the side, and this is the stage as seen by the public. Here you can see the control room, and what we did is we took a mocap of Marco Borsato playing the intro of his song, and we did put him on the roof. So on the screens, people saw the roof of the stadium they were in. And Marco Borsato was standing on that roof, clapping, and at a certain moment, he jumps off the roof and flies to the stage. And which was actually very funny that at the moment we launched this clip and we launched this AR, the 50,000 people in the stadium were looking and searching for him, but actually he wasn't there because it was augmented reality. Let's have a look at the clip. So you can spot him already here on the roof, and the camera starts looking for him. And the people saw it on the big screens. Okay. So that was quite fun doing. I'm going to go a bit faster just to explain how all of this works. So we have, normally we have a cube LED wall. We have a 3D environment with textures and some game ID. This is the image you can see on the reel on the cube. This is the extended set. So in AR, we just add everything that's in 3D around. So this is the part you see really. This is added in augmented reality. And at the end, you have the combination of them all that goes out on TX. In terms of schools, we had a project in Michigan, which is actually the first university who invested in XR technology, not for research purposes, but for blended learning purposes. So they bought a set, and they are giving their courses and their lectures, like I'm giving now just with the webcam. They are giving their courses right out of the XR stage. They bought it in August 2 years ago, and during the Corona pandemic, they were the happiest customer we had, because the stage was booked like 16 hours a day, and all their lectures, which are not XR lectures, which are just their normal lectures, are streamed live from their XR stage. So it's a very small setup. I think it's 3 by 3 meters. Easy lighting. This guy's based again, but they have a few layouts, and we created for them a surface on an iPad, so they can switch themselves which cameras are active, because it's a multi-camera setup, and they incorporated Zoom inside the workflow. So we NDI'd all their Zoom and the laptop of the presenter, and they can just give their course standing inside of the XR stage, with the big advantage that the professor can see his students right on the wall, not on a comfort monitor. And when he starts talking to them, it's much more natural for him as for the students. So they had a lot more participants that stayed online, and almost all the teachers are extremely happy to be able to give their courses from an XR stage. Okay, I got an example from a colleague of mine. So this is not from me, but I actually really like what they did here. It's Scott Miller, currently working at for XR Studios in LA. And what they did, there was a big esports event where a lot of people played games. You all know how esports work. They play games. And they did rebuild the world of the game inside an XR stage, which made it possible to do replays of the game together with the real players. So bear with me. Two people play. One wins by killing the other one. Afterwards, they stand in the XR stage, they replay the game, and they are able to show to each other and to the public how it worked and why he won. It's sorry, play. So this is the map of the game they created, which is in AR. The desk with speakers is in XR, and it's so well blended together that you almost can't see it. So you have an overview of the map, and the players will come to explain what they did. So they just put now the desk inside the map, and there you can see live the players playing behind them. And when they go to replay, there's one part of the match where someone gets shot, and just inside the studio they can replay that part and talk about it. I really like the concept of this, and I think in esports there's still so much to discover and to try. I'm just trying to see if I can have, yeah, there you go. Those are the two players inside the XR stage explaining what they did and how it happened. So this is really a next level of esports integration, with the big advantage that instead of in a green key where they should be looking at comfort monitors, here they're just inside the game and they can point at things and show how it went. I really love this. It's not my work, but I really love this work from Scott. Okay, we had some history. We had what we did today. Then there's what's next for me, because I'm a researcher, so always at the lookout for something new. I have a few things that are quite important for me. That's first of all virtual shadows, because you're always working on an LED floor. You can use real lights on it, but if you put shadows on it, it becomes very complicated. So we have been experimenting with virtual shadows and reflections.
Hi, welcome to White Light Smart Stage at this year's IBC. We are in Hall 8B15. We're back a year after a really successful time at last year's IBC, and one of the areas everybody wanted to look at was how do we do virtual shadows. Well, here we are, virtual shadows within the Smart Stage.
Some research footage. And actually what we do there is we take a camera, and there's some AI involved where there's limb recognition based on video. We reuse this limb to create a 3D model inside Notch or Unreal, use that as invisible to render, but casting shadows. And those shadows are generated inside the game. Which is, as you saw on the demo, still with some delay. So there's still some work to do to get this up and running, but it's very promising. This whole AI part that will add a lot of features that we can do in real time for now. So my research is going in the direction of AI to find solutions for things like this. So it's based on this limb recognition.
This is called motion capture technology, and until now has only been available to people like Hollywood movie producers who could afford the expensive, specialized equipment required. By helping computers make
this is based on Wrench AI, with the second big advantage that the software can also detect who is who. You can see these little numbers above the people. This means that you can track who is where. And you can say, okay, the first one you see will be the presenter. And you can take this a step further and take your, for example, your cameras, calculate a position for example, here, number 11, and tell your camera 1 and 2 to always follow person 11. So there's a lot of AI that can be used. This demo is like a year old, I think, and in the time now there is already an app available from Wrench, which you can just put on your iPhone and stream real-time the limbs to your Unreal Engine. So if you want to play with it, head over to the App Store and search for Wrench. It's here in the back, you can see it. Okay. Next very big thing that will hit the XR stage is things based on volumetric capture. I can play the video. It's not my work. We ourselves are not working with volumetric capture yet. We're using a lot of photogrammetry, but we're definitely looking into adding volumetric capture to the tool set to create virtual models and virtual 3D parts that you can use. Let's have a look.
So we're here at Dimension today with Sky Sports and Nikon for a final production test. It's the first time volumetric capture in our new mobile studio have been used for this innovative live broadcast at the Open at Portrush. It's pretty exciting. Let's go and see what's happening.
Ultimately, what we're really doing is, for the first time ever, we're visualizing a golf swing in all of its dimensions. That takes an unusual combination of an incredible camera company, an incredible robotics company, an incredible capture company, and a broadcaster that really pushes the limits of what could be possible.
This is the first time this will ever be seen on TV, and the end result will show players swinging in the open zone so that customers watching on TV can see exactly what their swings look like.
And we have the ability to bring augmented reality graphics into there, so if someone's having a great round, we can bring them in, and then we can have our pundits analyse the swings like never before.
This is a world first in that we are capturing golfers using volumetric video and motion capture all at the same time to make an asset that's never been seen before. And that is essentially a holograph of a golfer that can be looked at from any viewpoint, and time can be frozen at any point in the action that we've recorded, so you can look around and look at their golf swing. Golfers have never been able to analyse or understand their movement and their motion to this level of detail.
Yeah, just skipped one because I would like to keep some time for some questions and some discussion. And one of the next things, it's starting to happen. There was a big stage being built by Intel.
Fast forward approximately 100.
Where they go a step further and where they did build the little tent we saw in a very big stage. I understood it has been closed in the meantime. I don't know why. I think it's just too expensive for now. Maybe if someone of you know what happened with it. But I want to show it anyway. It's the same thing as what they did on the golf, but then on a large scale.
150 years. And another such transformational moment is about to take place. Here, inside an unassuming soundstage near Los Angeles International Airport, the next great innovation in motion picture entertainment has been under construction for more than a year. 25,000 square feet of total studio space, a 10,000 square foot volumetric capture area, 5.1 miles of fiber, 10 petabytes of on-site storage, and a nearly unfathomable amount of compute power. This is Intel Studios, the world's largest and most advanced volumetric video capture and creation facility. Designed to harness the power of data in new ways by capturing motion performance in 3 dimensions, and via more than 1 billion points of light. The scale and scope of what the studio makes possible represents the next great transformation in the art and craft of producing motion pictures, offering an entirely new way to create more fully immersive and interactive experiences, even ones as challenging and iconic as A Horse in Motion.
And then the next step, which we are currently working on, is extended reality in live performance, where you can make a reel on a large scale, and then we are talking arena scale, XR set where the band is playing in, which makes great things for the live viewers at home, but it's still quite impressive for the people that are attending the real show. So those are the domains I'm currently working on to get it ready. So that was a very, very fast overview of what we've been doing the last years and where it's heading. I would like to take some time because I actually really have to leave afterwards to maybe take some questions or some ideas or some things you want to talk about. Just shout or let Carlos, sorry.
Yes, thank you very much, Maarten. So let's open the 4 questions. We have about 10 minutes, 15 minutes, and then we'll do a 5-minute break before my next or the next speaker. So let's open the questions.
Maarten, it's
Yes.
April. Could you talk about budgets a little bit? So, for example, we'll take the University of Michigan example. What kind of, some of us here, I think, understand the hardware investment up front, but can you give us a range of budget, for example, the concert that you showed and maybe a sports set versus the university?
I think you have to the arena show. I have no idea about the budget. I'm actually really the wrong guy to talk about budgets. That's one of the lucky parts of my life. I don't have to worry about budgets. I get asked to do things. But I do know I'm actually in the process of building a little set here for the school, and I think I get it down to 200,000 euro. So for my mini set where I can do everything and work on it with the students, maybe not broadcast ready, but good enough for concepts and learning how it works and experimenting. I think I'm at around 200,000 euro. The Michigan set should be around 500,000 euro, I think. Which includes a team of us flying in and setting up and creating the interface, and might be something like that. And the big stage we use for broadcasts, I think it's around 3 million euros with the full LED and all the tracked cameras. There we have a multi-camera with I think 5 tracked cameras, with the rails from Panasonic, all robotic cameras, green key attached to the side to do teleportations, and like 4 big disguise servers, a real mixer. I think it's about 3 million. So those are a bit the ranges we're in. But there is a very active community, mainly driven by Epic and Unreal, to get this down and smaller. It's also one of my researches that I'm doing. That's how can we take this new technology that costs a lot and make it affordable. There are guys on YouTube who created at home with 3 TVs, one HTC Vive and a laptop. I think then for like 10,000 euro, you have an XR setup which works. So yeah. Those are the. But if you give me 5 million, I can give you a bigger stage.
I'll find a
plan. It's always the same. The more LED you have, the more surface you have, the more you can do. If you look at Mandalorian, I don't know the price of the stage, but if I say 300 million, I won't be surprised that that's the price. But the more, because we solve the fact that we don't have that much LED by working with the set extension, which works, but which makes it difficult to integrate audiences. So you're so limited to this little space of LED. So if you have the money, just buy LED. And actually, I am convinced that the best XR stage that you could build that would have the least problems is a dome shape. So the day you can build a dome, even the best one is a circle, it's just a sphere. Build a big sphere in LED, make a plexi floor hovering in the middle to put your camera and your talents on, and then you won't have this color calibration problem anymore. Because when your camera is looking at the LED, it's always looking in the same angle. But there's nobody that wants to put up a dome in LED for me for now, but it's coming.
There's Maarten, do you want to do your own questions? You put it on chat, I saw, but.
Yeah, I had a couple really. I think there's 2 questions. One of them was, what do you think is going to be the toughest technical challenge coming up in the future? And also a second question is, do you think that Unreal is going to continue to dominate this, or do you think there's going to be a specialist tool developer? They're both in the chat if you want to see that.
First of all, which is maybe surprising, but the biggest challenge we actually did. I haven't got it in the PowerPoint, but we did in January. We did the first full live broadcast multi-camera TV show with 50 persons in the audience, which were with occluded objects traced out of the set extension, and a really complicated setup. And actually the biggest advantage and the two big problems. First of all, timing is king. The big problem when you go for XR is that everything has to be gen-locked. And not only gen-locked, but also calibrated to each other. Because every camera you use has another delay. Every server you use has another delay. If you start to combine multiple servers, because your surface is so big, you need to get them locked. But there's nothing to lock on because it's just a thing that's rendering. And there is a kind of variation in delays happening. And that's the most difficult part of it all, is getting control of this data stream, because it gets so extremely complicated.
So essentially there is, particularly, you're talking about kind of multi-camera setups. So I suppose there is essentially at some point an upper limit for multi-camera setups, like how many cameras are really even possible within virtual production.
Depends on server power.
Okay. Okay.
give me those RTX cards that all the Bitcoiners are buying. Yeah, no, it's a technical limit.
Okay.
It just, you need power to get, you need power, and something we forgot during these years, you need buffers. So there should come in all components you use a kind of buffer system where you can store frames. And once they're all, you take the slowest one and you time on the slowest one, and then you will get in sync. Because now if the director wants to cut, you need to cut to the right camera, but the right content needs to be put on the screen as seen from that camera. So if there's even 1 millisecond of delay between those two, you get a black frame, which you don't want live on television. So the biggest advantage is technically buffers and timings. And the second biggest problem, and that they will like to hear on Breda University, is production. Because your complete workflow is changing. Instead of recording your show, doing post-production, there is no post-production. So all this post-production has to move to pre-production. But people in the industry today are not yet used to it. They're not used to work in a virtual world in advance on a laptop and then see it come to life. So they only see it like they treated it like a theater, where you have the premiere, where everything comes together. But actually, it's not that. It has to come earlier. All decisions have to be made in advance. Your découpage, I don't know the word in English. Your camera shots.
Yeah. Collage.
You have to do them in advance. Because you can't just play around and say, okay, we're going to do some free cutting. Not yet. It's coming. So the competences of the people involved in your production are changing. And I think there is the biggest challenge. Because now we have camera people that have to move a crane to go and film something that's not there. We had a Steadicam running around all over the place. So we created for him a special view on his monitor where you had a wireframe of the world. Because if you put a real world, he can't see the actor who's behind. So there's plenty of, but he had to adapt to this new style of working. So the guy is running around in an empty studio, but you want him to run over a bridge. So it's a complete new way of working for a lot of people. And there are some people that just go with it and they have it. But as a big part of the production, mainly if you work with classic production companies, there's a lot to learn for them. But it's coming. It's
interesting. And the second question was, do you think that Unreal is going to continue to be the main tool for this, or do you think there's somebody else coming up that we need to also look at?
Unreal has one big advantage. They have Fortnite, which generates so much money that they don't know what to do with it. Maybe the person who will come after me will say other words, but they're the only ones that have this amount of money to invest. They're buying every company that's doing well in this area, they're just buying it. So I'm quite sure that for now Unreal will stay the main engine to use. And there come integrations. I do love Notch. I'm an old Notch user, but I also use Unreal now, just because the renderings are faster, are better,
It's really good tech.
I see people working on integrations between Notch and Unreal. So I think Unreal will become like your engine, but then there will be, like they do already. I've in the studio here, I work with those Panasonic 3D cameras. I just have a plugin for Unreal. And I think this world of plugins will be where it's going to happen.
Okay, interesting. Do you see any issues with things like fluid simulation of mist and things like that? I mean,
Yes,
I saw the yeah, okay, yeah.
Power, processing power. That's so for all the game designers that are on this meeting, learn to use all your tricks to get the power you need to create what you want lower, because it's even if the computers get faster, we will do more with it. So it's very important to learn to strip down your scene. I think now I'm talking for Notch, I think I spent like 30% of my time creating content and 70% of my time getting it run at 50 frames a second. It's really like that. So it's more of a technical job, how to get your textures smaller, how to rethink reflections, because yes, there are ray trace cards, but forget that you can do real-time ray tracing at 50 frames a second on a 32,000 pixels canvas. You just can't.
Yeah, we've seen that a lot of times when games dev and film have collided, that film is so used to, it's like, oh, I can render one frame every 10 minutes. Cool, that's fine, as long as it looks beautiful. Yeah. And then game people are coming in and going, yeah, I need to render 120 frames a second from two different camera perspectives. Just the challenges there. And it's interesting with virtual production is kind of smooshing those two even closer. That's interesting.
Absolutely.
Thank you for the presentation. It's been really interesting.
It's a bit fast, maybe, but
oh, it's good. No, lots of interesting stuff in there. Anybody else?
Yes, more questions?
I can always keep asking things. But...
Well, actually, I also have a couple of questions regarding, Unreal is promising in really soon a different type of game engine that can support and automate the number of level of detail on a very high rate. We're going to be seeing things like massive landscapes fully polygonized and so the LED will be managed automatically and etc. Do you think that will change a bit of perspective of the technical side that requires to go to that optimization process, and we're just going to rely on the technical challenges that rely on the technical ability of the new graphic cards and just wait for the next big advance on NVIDIA or anything?
I'm an all-time VJ, so I played visuals in clubs and like 20 years ago, and every time there were faster computers, we were the first to buy them because we had these massive screens to play. And every time there's a new technology, there's a new computer that's more powerful, we just went up with the number of layers of video we could. You always go to the limit. So this technology, yes, it will help. It will make bigger canvases, and you will have more detail or better level of detail. But people will always tend to go to the limit of what's available. So the key point and the added value of the guy who's creating it will always be in his head. And that's really something I can't translate in English, but gezond boerenverstand, what we call it in Belgium, it means clever thinking with your foot on the ground will get you much farther than new graphics cards of new technology. Of course, this technology helps, and it's evolving every day. And now we have N-display in a difficult, but it will get better. But at the end, it's the knowledge of the guy who's operating the thing and who's using it that will make the difference. So that's why we are at school, to try out and to understand. If you understand the complete flow of what's going on, that's very important. That you understand the complete workflow of this thing. So you can take the part that slows everything down and work on that. But just by having the technology, you will never understand that it's the texture size, for example. I take an example that will be your problem. oh, that's the lighting, or that's the reflection. So it's very, very important to know your basics. And the basics in Unreal are here to stay. I mean, we're not going to have a new lighting system next year. We're just going to have more lights because they added DMX and ArtNet. It just makes it more complicated, which now is one of the weakest points of my settings is my network card, because we're pushing 34,000 ArtNet addresses through it. So who would have thought 2 years ago that the weakest part on our media service is the network card?
On another note, you mentioned that AI is playing a big role in to support your developments. We strongly are working hard on also keeping up with that developments in terms of AI. What do you think would be the good bets of AI developers in terms of media and 3D management? So we've been seeing tackling so different aspects from liquid simulation, to smoke, to trying to get a bit higher rates in terms of fast and optimization, so scale up the number of pixels and stuff like that. But also we can see other developments in terms of characters, and like you said, like human recognition, stuff like that might be useful for live performances. So what would you, from all of those different types of fields, do you think would be the most, and based on your experience, most interesting for AI developers to focus on?
For me, it is very strange to say, because we come from this green key, where we had a key around our talents. We moved on to XR, and we're explaining to everyone, we don't need a key, we don't need a key. I want the key. I want my AI to be able to key out my people from this LED screen, because then I know where it is in space, and I can make things turn around. I can make things switch between front and back plate, and I can finally make money by creating a stage that has another content on it when it goes to China and when it goes to Japan, like they do already on the football stage, where you have other publicity around. I would really love to find an AI solution to key out my talent from the stage, including his 3D position, for every finger, every nose, and it can't be that hard, because it's a human being.
There is some solutions especially focused on depth maps and stuff like that, but I'm not sure if they're actually real time, although there is some solutions there. But yeah, thank you, Maarten. I think that was it. I'm going to be closing for questions, because we're going to have Emanuele coming next. Thank you very much for your time.
You're welcome.
Thank you for the presentation. And I know that you have to go because you've been locking down in Belgium, so you're going to be spending the afternoon going around and try to finalize all the details, because on Monday you're going to be closing shop. So thank you very much for your time.
We're actually moving out the servers now, so we can have them outside the school. Okay.
Okay. Thank you very much.
See you next time.
Thank you.
Bye.
Bye. So hello everybody. For those that arrived late for the presentation, we're going to be just working on talking about future productions this afternoon. We just had Maarten from AD Studios. We're going to now talk with Emanuele Salvucci. We're going to be doing a presentation about future productions. I just want to remind everybody the rules very quickly. So if you're not speaking, please turn off your cameras. Please mute yourselves. And if you have any questions, please reserve them towards the end, so we can actually have those being showcased more towards the end instead of interrupting Emanuele. So Emanuele, maybe you can take it from here.
Yeah, I don't know if you want to make a break, Carlos. That's fine for me.
Let's reserve the
Yeah.
break for after you. I plan, so you're gonna have like an hour talk,
Right.
more or less, with some questions, and we're gonna do a break before the next person, Mark, that is coming after. So let's reserve that for afterwards.
Excellent. Okay.
Thank you.
Thank you. Yeah, hello everybody, and thanks to Carlos, of course, for inviting me. Yeah, I'm coming from a different, background. So I've been in games since 1998, professionally. I've always been curious about the game development since I was 16 years old, probably, with the Amiga systems. So maybe someone remembers that. Yeah, I've been working a lot with Revolution Software on adventure games. Basically, that's the Broken Sword saga, basically. And lately with Beyond the Steel Sky, which is a remake to the 1995 game Beneath the Steel Sky, which has been lately released on the Apple Arcade service. This one for me is the second virtual production fellowship with the Epic Games as a teaching assistant. So I've been into really virtual production for not too long. That's very new for me. Although I've been in computer graphics for a lot of time, so I'm getting lots and lots of feedback from people coming from the VFX industry, and so that's very interesting. I'd like to share that with you. And also, I've been like 4 months consulting for MPC lately, moving picture company, on the retro production for the announced The Lion King 2 movie. That was an extremely interesting experience. Of course, that was hands-on, of course, in a real engine. So let me get started by sharing the screen now. And this one. Cool. Is that okay? Yes.
Yeah, that works. Yeah.
Yeah, perfect. Thank you.
Excellent. So yeah, I'm with Prometeo Lab, which is a UATC, which is an Unreal authorized training center. Of course, I'm an authorized training instructor as well. We are in Rome, Italy, and we partnered with Epic Games for remote training with this pandemic going on. Last summer, basically. So we trained people remotely with the Parsec technology, which is used to control remote machines at 60 frames per second. And so just a little note about that. Believe me, it's really, really different. I mean, we had people turning off our machines thinking they were their own computers. So I mean, that's fantastic. So in case you need to do remote stuff, just head to Parsec as a technology. That's my suggestion for that. Yeah, so let me get started with that virtual production. I said it's quite new for me. So it doesn't even exist. I mean, if you search for virtual production, you won't find that on Wikipedia. So that's kind of unusual. The best you can find is virtual cinematography, which is a little bit of different topic. I mean, you can see that it's working with real objects, mixing up real objects and virtual objects and virtual environments, and doing the CGI. Really, that's the kind of a VFX definition for it, I guess. So it's really, really new. Can we try a possible definition for that? I would say that, of course, my humble definition, my humble opinion on that is that we should shift the meaning of virtual production being possibly interactive, immersive, and in real time for it to be called virtual production. Possibly that's, for me, a way to identify what virtual production might be. And that's because compared to the traditional VFX pipeline that we have here, you see that's a bit old, but it still applies to current VFX production, is you got all the pre-production and production stages. You got the modern rigging, animation, and all that, and then you got this little tracking and match move, which is interesting. We get to that in a bit. It's all done offline. It's all created with all the time you need to make the assets, to do the shooting, and to composite the final result into your movie. So it's basically we distinguish that between offline and real time. So yeah, basically that's why I'm focusing on the tracking and match moving, because basically the virtual effect, VFX pipeline substantially relies on this, which is our good old green screen. So everything that's been done till now, it was like, okay, let's have our actors, our live action, let's green screen them, and then we composite and make the visual effects in CGI and then put them together, which is different from virtual production, which is different from being interactive, which is very different from being inside the environment, because as that pipeline was offline, basically means that directors, the DOP, director of photography, and all the people involved in the actual movie, live action shooting of the movie, weren't aware of anything else but the live action they were shooting. And if the movie had lots of visual effects, lots of computer graphics, that's going to be a huge problem. I mean, you don't know, you don't see it, you don't know where things are. I think Maarten also focused on that in his talk, which is really true. I mean, that's the real problem. So I think the seminal work in this sense was provided by Avatar, the first one, the movie in 2009. So yeah, James Cameron saw that issue and said, okay, I got a world that's basically 99% CGI. I mean, the movie's got really few scenes with the real characters, with live action, and that's not much. That's covering just a fraction of the movie. The rest is all CGI. So I'm not seeing anything. I won't probably make this movie, in a room with computers. So it was like, okay, let's, he devised the virtual camera thing, really, because he just made it up. And, it's a monitor that allowed him to walk through a version of the environment that was built on purpose to be navigated in real time, so that he could move in the virtual stage, even though it was in his monitor, so it was not like using LED walls or anything like that. But at least he could kind of walk through the environment. And basically, yeah, in essence, Cameron says that he allowed that to direct the film as if it was a computer game, which is interesting. I mean, we introduced some of that concept already in this presentation. And of course, he said, yeah, that's super cool because he could do stuff that couldn't visualize before. So what's from Avatar, where we are now? I mean, of course, he's shooting Avatar 2. It's many years, I guess, now that this is going on. And as you can see, all the equipment that he had before in 2009 now became that little monitor with a pair of joypads attached to it, which is a tracking camera monitor. It's a virtual camera it's handheld. I mean, it's a monitor into the scene. So there's an actor there with the motion capture suit performing the action, and he is looking at possibly a version of the virtual character performing the same moves in the CGI environment running in real time. So that's the vision he possibly had at the times for Avatar. And now it's very much into how you should possibly shoot a CGI movie today. That's a big shift in in the whole VFX world and production world. That's a big one. So yeah, Geoff Burdick, which was in charge of the the data and production of some of that. See, the focus is that we need to look at it now on stage, real time. We can't go back and forward with with post-production studios doing that the 3 months prior to release of the movie. I mean, that's the whole post-production pipeline that's been going on in the movies industry. So that's not the case anymore. We can do that real time. We can see it live together with the live action. So that's a big thing. Of course, many of you know about The Mandalorian. That's been a big, feature with Epic Games as well that helped ILM, Industrial Light and Magic, build the stage with the LED walls. I think it was at the time the biggest in the world, possibly, of course. Allowed to shoot the Mandalorian 50%. I've read of the Mandalorian season 1 series with the LED wall stage. So yeah, all the action was played back. All the environments were played back interactively on the LED screens, and there was also editing of the some of the post processing in real time during the shooting. That's because this a little bit is as a definition of that is in-camera visual effects, which is even another thing. So the steps here, the idea here is that you completely eliminate the need to go into post-production as well. I mean, what you see in the camera, what you are shooting live on stage in that case, it's good enough. I mean, it's already output material that you can actually stitch together to the final output. I mean, you don't have to do anything else. That's the final thing, which is a big thing again. So it's changing a lot in the movies production, this kind of workflow. Really briefly, it's what people is using here. It's using lots of stuff. It's using lots of gears, because of course the idea is that you blend together two worlds. You blend together something that doesn't exist. It's just in the computers and your live actors, your live action. So you need lots of things. You need the virtual camera. You need for the in-camera visual effects, you need the LED walls, possibly. You need the camera tracking in many situations. Scouting and pre-visualization, virtual cameras and head-mounted displays. So the VR that's used for games, that's actually useful for scouting and editing the environment. So Epic Games also showed that they got some tools for virtual production dedicated to that, that allow you to move stuff around in the virtual stage through the virtual reality headset and controllers. So I don't like that rock on the background. Just move it a little bit on the right. The director is on stage, and you can do that. I mean, that's being played by Unreal Engine in real time. So that's if you build your set to be interactive, you can do that. You can change the lighting. You can have different colors. You can color grade. You can do everything you would do in post-production. You do it in real time. Of course, there's performance capture. So it's facial performance capture happening in real time. You got head-mounted camera, HMC. You got the motion capture suits running. You got the motion control for the cameras, so the focus, the zoom, anything about the hardware of your camera, so that you can later on post composite as well if you need. That was a note to self to mention the VAD. I mean, that's nothing to do with the techniques and the gears, but just to remember that. There's now a thing in a VFX company that's called VAD. So they're actually changing a lot of their internal workflow, including a virtual asset department or virtual art department that's totally dedicated to building the assets for this kind of workflow. So it's very early stages for virtual production. I think someone says it all began in possibly 2019 globally. But they already have it. They're already structuring internally like that. So it's more than happening. A little bit of looking at that in perspective is how that became possible. Yeah, thanks to this. People might think I'm biased, of course, because I work a lot with the Unreal Engine and Epic Games. But yeah, as Maarten said, there's actually quite nothing else like that allows you to do that. I don't want to talk about Unity. Unity is another game engine, of course. It's all about the focus. I mean, Epic Games been focusing on virtual production for I think more than 2 years now, which is not a lot of time, but they're kind of a big company. They have lots and lots of programmers, so the firepower there, it allows them to get results quickly, and it shows, it demonstrates because they focus on that and they got immediately lots of results there. The first demo there is a technical demo done with the ILM in the Star Wars universe, and that was demonstrating the ray tracing. So that scene is totally real time, it's totally virtual, it's no live actors there. So game models, if you want to say that. The only thing is that they look so realistic, you could say that's a movie. And that was the point of the demo. Of course, it's not just thanks to Unreal, which is a software. That's also something else in the background, which is the hardware technology provided by NVIDIA with real-time ray tracing. Again, that's a recurring word, of course, which is actually, I got that often from the fellows in the fellowship, which is, yeah, I don't have an RTX card, and ray tracing is not. And I said, yeah, it's not really just the graphic card doing that. It's actually a software layer first. It's an API. It's provided by the DirectX software library first, and then it's accelerated on the GPU. So that's why actually Mac computers cannot do ray tracing, because it's not. I don't know when that's coming on the Mac. It might be coming on the Mac, but they don't have Windows. So of course they have OS X, and OS X doesn't have DirectX, and DirectX implements ray tracing on the software layer. So yeah, that's a no-go for that platform. So yeah, it's two things together. It's the software layer, that's the hardware accelerating that, and it's a big thing. I mean, ray tracing, it's a general purpose algorithm. It's a computer graphics algorithm that's been around for a lot of time, and all the offline rendering happening for the traditional VFX pipeline, all the software doing offline ray tracing, offline rendering, they do ray tracing in some way or the other, some technique or the other. Might be Monte Carlo methods, might be whatever else, global illumination, path tracing. It's still fundamentally ray tracing algorithm, and of course traditional that's been offline because it takes. I can't remember who said that, but yeah, possibly someone at MPC. They said, it takes hours for a frame of the Lion King one, and I mean hours with the hardware they have. It's a lot of time. It's a lot of processing power. Considering that these guys introduce ray tracing in real time, it's a big thing because, as Maarten said also in his talk. In the games, from the input of the player, let's say you have your gamepad in your hands and you push a lever, you push a button, what happens is that in order to go to at 60 frames per second, that input is taken by the engine. It's run through all the systems of the engine, which include either physics simulation, include the gameplay logic, the inputs, the audio, the AI, the rendering system at the end, and then it presents a frame. And we got 16 milliseconds to do all of that. I mean, not just the rendering, it's the whole game engine that runs. Every frame takes 16 milliseconds from the input. So it's a lot, it's a huge difference from offline rendering. And actually, it became possible for these technologies, but it really, we need to thank these guys here. I mean, we need to thank the games. I know, again, I sound biased here, but I'm trying to be a little bit objective. Doom, it was possibly the first person shooter. I mean, Wolfenstein 3D was the first one, but from the same person. That was John Carmack, founder of ID Software, and of course Unreal. That was its direct competitor at the times, 1993 and 1998. So why I mentioned that? Because at the times of Wolfenstein 3D and Doom, there really wasn't any 3D graphic cards. There weren't GPUs. There were, 2D accelerators for Windows. Some of you remember maybe that. So the graphics wasn't seen as fundamental in personal computers at the times. Personal computers were used for other things. I mean, the engineers were using those for, computer-aided design and stuff like that. So the games were kind of marginal until Doom and Wolfenstein 3D came out, and the demand for playing first-person shooters became huge. I mean, the market and the people demanded more and more of that. I mean, it was massive. And of course, the companies producing the 2D accelerators for Windows said, "Oh, that's interesting. I mean, that's that might be an even bigger market for that applications, 3D games," and they started producing, 3D accelerators. I very much think that if it wasn't for that kind of traction, we might not have had even our smartphones today. I mean, I don't think I'm exaggerating here, but it's actually, I lived that period quite directly, and I remember how it was very, very, very clearly. And I can say that, I mean, possibly that's history changing. Of course, Tim Sweeney, which is the founder and CEO of Epic Games today, he was the main programmer for the first Unreal game. So that was, as he says, he wrote 90% of the code in the engine. So he made it. And of course, that was a big achievement. And they, of course, made a bit of money there. And that all got traction from that point on. And of course, since I'm not a scientist myself, I met with Carlos during a conference on games where I got a technical paper accepted. Possibly to these super scientists. I mean, I follow some of them since they began their work on HDR in 1998. Especially, I've had the fortune to eat a sandwich with Greg Ward-Larson at a SIGGRAPH. That I was following them since the early stages, and if it wasn't for them as well, I think that wouldn't be evolved into the movies, into some of these specialties that we see now, because they created the fundamental research behind many things that we see now and we use now, or even Unreal Engine implements in its code actually. So yeah, Greg was possibly the father of HDR format, because he came out with the RGBE image format for his Radiance software that he created for his students. And that was, yeah, kind of 1996, 7. Paul Debevec is still very active, from what I get in consulting for the movies industry. I mean, he's the main movie researcher. I think I see him as a superstar, really. I mean, he's the guy behind. He evolved the system from Greg Ward by capturing the HDR images and relighting the subjects, and of course introduce photogrammetry. I mean, he produced the first ever, I think, short movie, technical demo, of course, of in HDR, completely done by himself, not being an artist, but being a scientist. There's a video I will give you reference. It's called Fiat Lux, which is photogrammetry of the internal of the Basilica of St. Peter in Rome, that he photographed and reconstructed in 3D with his own software at the times. That was completely rendered in HDR. So he also captured the lighting coming into the Basilica, so that he could relight the 3D elements in it with the natural lighting. So that was kind of really, really seminal work for the integration of the virtual objects into the live environment using HDR. And of course, Helge Sitzen, met as well. He is the pioneer of HDR displays. So today, if you go buy a television, you most probably you want the 4K, of course. But the guy there selling you the television will say, okay, that's the HDR as well. And you say, oh, that's fantastic. I mean, that's a great feature. But he actually he was the first one making the LED technology that was able to output HDR kind of videos. So he's now, I guess, he's with Dolby Vision. That became, they were acquired by Dolby as well. So he's working with Dolby at the moment. So yeah, thanks to these guys, because they're really superstars. I mean, what's next? It's been announced. I mean, Unreal Engine 5. Yeah, game technology is it's been like, okay, I can see the image here, not this one. I can see for some time that's been, yes, that's a game, and the other one is a movie. You can tell the difference between a game graphics and the movie visual effects. Okay, the quality, the amount of detail, you know, the number of objects you got on screen and the effects and all that. What's happening now, Unreal Engine 4 is already very realistic, that's true. But the things we've seen in the Unreal Engine 5 demo, they're shifting the whole market and the whole industry, because the thing you see on screen now on the right, it's simply not possible with any technology that you have now. Even, of course, not with the Unreal Engine 4, otherwise there wouldn't be a point to make a 5. So, but what you see there, it's running 60 frames per second on the PlayStation 5 hardware. I mean, it's 800 euros of hardware that's running movie quality assets, and it's lighting them in real time. So that lighting, that global illumination, that all bouncing the lights, it's all dynamic. This scene is comprised of, you know, possibly 30 billion polygons on that kind of hardware. I mean, that's really a game changer that's coming, I think, very soon. So that changes a lot. Of course, Weather Digital, that shows us the how you can actually produce an entire a short movie with a Unreal Engine without virtual production. Is about, you know, mixing live action as well. But if you want to do this kind of movies, short movies, CGI movies, you can already use Unreal Engine and do it yourself. I mean, they just demonstrated that. Of course, that's Weather Digital. It's got a huge amount of experience in the movies VFX. But as Maarten said before, Unreal Engine is still an engine for game development. So that shows that VFX studios can, of course, take on, you know, a tool that was designed for the games and make it work to make short movies of the highest quality that you can see now. What's next is, yeah, movies done completely in CGI in real time. What does that mean? I mean, I'm keeping this for kind of the end. What does it mean? It means that you can do hybrid movies, that you can have virtual actors, that you can have meta-humans, as they call it now. The very interesting thing was that the image of that's called the human race. That's a technical demo by the Mill together with Epic Games, showing that they could shoot the live action of the environment and have the cars completely made with a real engine. So the cars there are not real. They're added on the live footage in real time. So you can actually have a movie running in the background and swap the cars, because the cars are not getting in the video stream. The cars are made by the engine in real time from your device. So you can actually get your remote from let's say, the television in the next future and swap them, because they're not coming from the video. It's your hardware making them. So let's say that you're watching a movie with I'm staying with the old Hollywood actors. You're watching a movie with Tom Cruise, and you want to swap him for Mel Gibson. And you know, the rest of the movie stays the same, but since the actors are virtual and they're made up by your television, you could swap them. I mean, at least that's the future perspective I got from their demo. They demonstrated that's possible. You can do that. Of course, with the announcement of MetaHumans, which is very recent, we get a glimpse into it, as how good you can get at making virtual humans, even with the Real Engine 4 that's running on current technology. I won't even think how those could be in a Real Engine 5. I mean, that's going to be much better. So yeah, that's kind of the future that we probably will see in the next years with the real-time technology. Another thing I wanted to say is that Maarten actually mentioned on the VFX production pipeline. Yes, so we're all using a Real Engine at the moment, mostly. And what's the specialty there? Especially for the students, we got a lot of people, I said, from the VFX industry. We got lots of students that are much younger. So what should I become? Should I become an artist? Should I become a programmer? Should I get into games? Actually, the worlds are merged together, but it is still true that the underlying technology was made for games. And I don't think that will change very soon or into something else. I don't think it won't adapt to any industry, let's say. Of course, you can still build on top of that, as Maarten said as well. You can make your own tools. You can, simplify the workflow. You can do whatever you need to do in your industry, but the underlying technology will still be a game engine. So on that matter, I always say that the person to me that relates more to a software like that is called to me a technical artist. A technical artist is the person that he works with the computer graphics software. Might be Maya, might be Houdini, might be 3D Studio, whatever software that you like. Understands the polygons, understands the geometry from an artistic point of view, is able to build some of them, is maybe a 3D animator. He rigs characters and stuff like that, but then he also understands how the rendering pipeline works. He also understands how to make tools for the engine. He knows about programming, some of that. It doesn't have to be an engineer, but is the glue really between the two worlds, the artistic and the computer graphics world and the programming side of it. In games, we often talk to programmers. I mean, that's how I became, at the times, I became one of the first possibly technical artists in the industry, along with other people, because we were tackling technical problems, because we were frequently talking with our programmers working on the game, and we absorbed all those concepts, and eventually, went on some programming languages and tried ourselves. So we became technical artists by learning by ourselves. So yeah, all I can say, that's how you the technical artist is very much sought after today. I mean, if you look at job posts, apart from real people, I mean, the definition would be we're looking for technical artists to join our studio and working on Unreal Engine, because they know Unreal Engine is mainly a tool for technical artists. So yeah, that's my suggestion, and I will close here, Carlos, if you want, because if there are questions. And now, of course, I will leave time for the break that you mentioned. I don't know if it's too early. Yeah.
Okay, thank you.
You're welcome.
Let's open the floor to questions.
Yep.
Thank you, Maarten. He's just thanking you for your talk. I'm not sure if you can see the chat.
No, let me see. I didn't open the chat.
Okay, so I know you've been working a lot with Unreal Engine, yeah, we understand that the Unreal Engine is a major pillar in industry. But what other tool sets that you think would be important that they're currently working, or would be important for us to look at the moment in terms of support tools for the industry?
Yeah, absolutely. Well, the assets, the graphic assets, you still need to build them. I mean, you still need modelers, you still need animators, you're still doing the motion capture. Although some of that is coming into a Unreal Engine, I think they're trying to have it all in one single place. I don't know how much to what extent they can have that. But definitely they're including, modeling tools and stuff like that. But apart from that, as the current situation is that you still build the asset, you're still doing the motion capture. The good thing, the great thing I've seen is doing the motion capture remotely, as it links with the Unreal Engine inside the Unreal Engine. So during the fellowship, we have motion capture sessions for our 100 participants. So they actually have a mock-up studio from one side of the United States, and then they have the performer on the other side of the United States, and they record the session in a Unreal Engine over the network, over the internet, on demand. I mean, basically that's great. So all the tools, as Maarten said as well, you can link stuff to a Unreal Engine. Basically it's your hub. All the other tools that you can, possibly try and plug into the engine, they're perfectly fine. They serve they serve your needs in your specific industry, be it the VFX, be it broadcasting or esports. It makes sense. So we're trying to building an ecosystem of tools around a central hub, basically. So if that answers the question.
Yeah, thank you. And you've been working as of late as a consultancy in the Lion King project. Can you disclose a bit of probably not a lot about the work you've been doing, but can you disclose a bit of maybe some difficulties that you guys are facing?
Yes, I can. Of course, I can't talk specifically about the project, but I can, put together a number of voices that I've heard in the virtual production world, especially in the fellowship. You know, the fellowship program. I don't know how much you know that. I mean, you probably know the name and stuff like that, but it's actually gathering people, professionals from the VFX industry and the movies. And actually, I found myself, I mean, I was kind of embarrassed because I found myself helping people that had maybe 2 or 3 Grammy Award, Emmy Award, and you know, some of them had the little statues on their back. I mean, for possibly winning an Academy Award, and they were learning Unreal Engine in the program. So I got a lot of feedback about that and say, okay, this doesn't relate to, you know, the terminology. First, one of the big issues is the words, really, the commands that you see in Unreal Engine, hands-on in the engine. That's the first difficult moment for people approaching the engine. Is they speak a different language. Just lately the engine implemented let's say the real world units for lighting, for instance. They're using lumen and candles. Unreal Engine wasn't using that before. I mean, we don't care in games. We don't care about the actual value for the light. Of course, in the movie, that's critical. I mean, the director of photography wants to know, okay, how many lumens is that light? How does it work? How does it bounce around? That's because that's a different job. So, yeah, Unreal Engine is adapting a little bit for virtual production. So it's including now those features. But the main issues with that is approaching the engine for what it is, not trying to make it something different, making the thing that you used to work with. I mean, I'm used with RenderMan. Yeah, in RenderMan I can do that. Of course you can. Now Unreal Engine is not RenderMan, so you need to, in a way, you need to adapt. You need to get the best out of the tool in this situation. So you can build your own. You can build your own workflow. You build your own tools. That was also part of the job there. It's trying to make the tools in the engine that allow, you know, the DOP to do its job as in a way as it was used to with different tools, not in a real engine. So that can be done. I mean, your studio pipeline can develop tools in the engine that adapt to its own workflow 100%. If you can make a game with the engine, you definitely can make the tools for it. And that's your own, that becomes your own world. I mean, that becomes, you used to customize your software to a certain extent, but a real engine being a game engine is totally different because you can make your entire own application out of that. It is so generic that you can turn that into your own production tool and real-time visualization system. It's totally your own, which is much different from, you know, yeah, I'm writing some tools for Maya or, you know, Udemy. Unreal Engine becomes literally whatever you want to become. I mean, that's its nature. Let's say, put it that way.
We have a question from Merlin. Is there any other skills that you think that can jump from outside of the game industry that will make his way into the Unreal and bringing even those tools together?
Other skills that, of course, oh yeah, definitely. From what I saw, animation skills, general computer graphics skills are always, I would think they're needed. I mean, Unreal Engine is, as I said, it takes rendering to the real-time level, but it is a renderer. So an artist coming from the, you know, any other offline renderer or a VFX CGI pipeline, of course, got the knowledge and can get to know Unreal Engine because it's not using, it might be using some techniques that they're not familiar with, but the underlying, technology algorithms and systems are still apply. I mean, they're still valid. You still have a skeleton with bones. You still have you have a control rig, which is really a rigging system inside Unreal, which is a rigging system that you have in Maya, as in Udemy and other software. So your rigging and animation skills are very, very useful there. Of course, you need to learn the rest, because then to make it real time, that's where we need something more. That's where we need additional algorithms, additional notions that allow to take those basic techniques and bring them to 60 frames per second. But you with all traditional CGI skills, you're in a very good position to get into the engine, of course, definitely.
Okay. Is there anyone else wants to make any final questions before we go for a break? You're welcome, Merlin. Okay, then let's resume back at 3 o'clock, where we're going to have Mark from Epic coming over and have a chat about future productions. Emanuele, thank you very much for your time.
Thank you, Carlos. I'm not sure I can stay because I got the fellowship started at 4. So yeah, it's unfortunate because it's going to be a pleasure to hear from the next speaker. But yeah, thank you a lot. Thanks a lot. It's been a pleasure.
Okay, thank you very much.
Thank you. Bye-bye.
So I'm going to keep the channel open, but let's take a break for half an hour, and we'll resume back just before 3 o'clock. Okay, thank you very much. Hope to see you in a bit.
Thanks.